In this video, we are going to discuss the problem find all the triplets with zero sum. The problem says that we'll be given an array and we have to find all the possible triplets of the index I, j and k such that the sum of those elements is equal to 0. And we have to return the triplets in the sorted order. So you can see here, suppose we have been given the array that is 0, minus 1, 2, minus 3 and 1. Now if you add the elements up, so what will happen? If you add 0, then minus 1, and then after that you add this element 1 as well, so the sum of these elements will be equal to 0, and the elements are respectively the elements are at the index 0, 1 and 4 respectively. Now after that, if you see the elements 2, minus 3 and 1, the sum of all these three elements will be equal to 0, and the elements are at the indexes 2, 3 and 4 respectively. So we'll store this particular triplet as well. Now we have only these two triplets which are going to make zero sum. So we have stored these indexes. Now how can we solve this problem? So there can be multiple ways. Let's discuss the brute force approach for solving this problem. The brute force approach is that we can generate all the possible triplets here. Okay, so we can try and generate all the possible triplets and check if they are making zero sum, store the triplets here. Now if you see, initially my I will be where? My I will start from here, my j can start from the next index of I, and my k will be here. Is the sum of the ith, jth and kth element equal to 0? No. Ask your k to move forward. Now your k is here. Is the sum of ith, jth and kth element equal to 0? No. So ask your k to move forward. Now your k stands here. Is the sum of the ith, jth and kth element equal to 0? Yes. 0 minus 1 plus 1, it's equal to 0. So I'll store this particular triplet here. So in the result, what I'm going to do is, in the resultant list, I'm going to store the triplet of the indexes 0, 1 and 4 here, because the elements at these indexes are going to make zero sum. Then after this, what will happen is, now my k gets exhausted, so my j will move ahead. Now j will be here and my k will be here. Is the sum of the ith, jth and kth element equal to 0? No. So ask your k to move forward. Now your k will be here. So is the sum of the ith, jth and kth element equal to 0? Uh, no. So my j will move forward because my k gets exhausted. So now my j will be here. Now k will start from here. Now is the sum of ith, jth and kth element equal to 0? No. So now after this, what we will do is we'll ask our I to move forward. Now my I will be here, my j will be here, and my k will be here. Is the sum of ith, jth and kth element equal to 0? No. So ask your k to move forward. Now your k will be here. Is the sum of ith, jth and kth element equal to 0? No. So now my j will move forward. Now my j will be here and my k will be here. Is the sum of ith, jth and kth element equal to 0? No. So now your j and k have got exhausted. Ask your I to move forward. Now my I will be here, my j will be here, k will be here. Is the sum of ith, jth and kth element equal to 0? Yes. So store this triplet here. So you'll store the triplet of the indexes 2, 3 and 4 because the elements at these indexes are making zero sum. So this is how you can do it. Basically, you can see that I'll be having one loop for I, then the next loop will be for j, then the next loop internally will be for k. So there will be three nested loop, one inside the other. So this will take order of n cube time complexity. Now understand one more thing, observe one more thing, that my ith index cannot go more than n minus 3 here, because after I need element j and k as well. So that is why my I cannot go more than the third last element. My j cannot go more than the second last element here, because after j I need a k as well. So my j cannot go more than the second last element, and my k can go till the last element. So my k can go till the n minus 1th index. Now if you see here, what we will do is we'll basically declare a resultant list. Then we have the n value. Then after that we'll iterate from 0 till less than n minus 2, because we'll iterate till the third last element only. And my j will start from I plus 1, and j will iterate till the second last element. Okay, that is why j is less than n minus 1, because j will iterate till the second last element. Then after this we'll have the k loop. K will start from j plus 1 till the end of the array. If the sum of the ith, jth and kth element is equal to 0, then we'll store this in the result, and then at the end we'll return this resultant list here. Okay, the time complexity for this approach is going to be order of n cube, which is going to be very high. Can we optimize this a bit more? Yes. What we can do is we can use the concept of hashing, but before even diving into it, let's understand the equation that was given to us. The equation was AR of I plus the AR of j plus the AR of k. The sum of all these three elements is equal to 0. Correct. Now if you take the sum of these two elements, okay, and you bring this third guy on the right side, you shift this third guy on the right side, what will the equation look like? Earlier the equation was the sum of three elements equal to 0. Now what will happen is the equation will look like sum of two elements, that is ARR of j plus ARR of k, the sum of these two elements is equal to minus of ARR of I here. Okay, the sum of jth element and kth element, basically sum of two elements, is equal to negative of the third element. Now what I can do is I can iterate in the array, and you can see that this is pair sum. So I can store all possible pair sum in the array with respect to the indexes as well. Okay, I can map the pair sum along with the indexes, and then I can check that if there is a particular ith element, and for it the minus of AR of I is there in the map, then this means my triplet exists. What does this mean? So suppose that if I have a triplet like this, let's say I've got 4 here, and after that I've got minus 3, and I've got, let's say, something like minus 1 here. Now what I can do is, if you will see here, let's say if I'll store all the possible pair sum, so you can see index 0, 1 and 2. Now if you see here, what I'll do is, inside my map, if I'll try to store with respect to the pair sum, if I'll try to store the indexes here. So what is the advantage here? See, the first pair that you will get is minus 3 and 4. So the sum is minus 1, and the indexes that you will get is 0 comma 1 here. Correct. Now after that, the next pair that you will get is what? The next pair that you will get is basically minus 3 and minus 1. So like this will be map of minus 4. It will be equal to what? It will be equal to the index 0 comma 2 here. Okay. Now after that, understand this. Now map of 3 will be what? It will be equal to 1 comma 2 here. Correct. So this is what is going to get stored in terms of pair sum, because we'll store all the pair sum with respect to all the pair sum. We'll store the indexes here. Now after that, if you see, so what I'll do is I'll start with this particular index. That is, I'll start from the 0th index here. Okay. Now when I'm at this particular index, the element here is minus 3. So whenever I'm at a particular element, I'll check for the negative, because see, initially in the map I have stored all the pair sum here. Okay, pair sum has been stored. Now whenever I come across any element, I'll check whether the negative of ARR of I exists or not in the map. If it exists, then I'll check further. So if you see here, currently I'll be at the element that is minus 3. Now when I'm at this element minus 3, so I'll check whether minus of minus 3 exists or not. So minus of minus 3 is 3. Does 3 exists inside the map? If you see here, so 3 does exist inside the map. Correct. The element 3, it does exist inside the map. What does this mean? Because I was looking for minus of AR of I, minus of minus 3 is what? Minus of minus 3 is basically 1. So since this is existing, this basically indicates that currently my index is equal to 0, and negative of AR of I exists. So this means that there might be a pair sum which can have different indexes, and all these three indexes can be different, and this triplet might exist. So if you see, I'm at the index 0, the negative of AR of I is 3. Now you check what are the other indexes stored. The index is 1 and 2. As of now I was at the index 0. You can see here, as of now I was at the index 0, and inside my map the sum 3 is present. So minus of AR of I is present, and the indexes are 1 comma 2. So these are different indexes compared to my ith index. So then I can say that yes, 0, 1 and 2, this particular triplet will be there in the answer, because this triplet is making the sum as 0 here. I hope you get my point. And obviously we'll store the result in a set so that we don't have any duplicacy. So the thing is that whenever I'll be at a particular ith element, I'll check if minus of AR of I exists or not. If minus of AR of I exists, then I'll check that what are the other indexes that are there. If the index is not repeating, in that case I will store the triplet here. I hope you got my point, how to identify the triplets with the zero sum. Because whenever I'm at a particular element, I'll check whether negative of AR of I is present or not, and I am at the ith element, and I'll check that if there exists a pair sum like this or not, such that the j and the k index are different compared to the ith index here. So this will efficiently help me to check. Let's see this further in the given test case here. So suppose that we have been given this test case. Now if you'll make all the possible pair sums, so you can see here that firstly the sum of this particular pair, that is 0 and minus 1, the sum is going to be minus 1, and the pair will be 0 comma 1. Then after that, the next pair is going to be 0 and the pair is going to be 0 2 as well. So you can see the sum of 0 plus 2 will be 2 only, and this will get stored here. Then after this you will see 0 and minus 3. So 0 minus 3, the sum is going to be minus 3, and the pair is 0 comma 3. Then after this, the last pair will be what? It will be basically 1. The sum is 1, and you'll store 0 comma 4 here. Correct. Now after this, if you will see further, so you'll be here. Now see, the sum is 1. With in the map, with respect to 1 you will store what? With respect to 1 you will store 1 comma 2 here, because this is the pair like index that you have. Now after this, if you see next up, so what will happen is minus 1 and minus 3, the sum is going to be minus 4. With respect to minus 4, you will store 1 comma 3 here. Okay, then what are you going to do? You're going to store this as well. You can see minus 1 and minus 1, 0. So with respect to 0, store 1 comma 4 here. So I've stored this in the map. Similarly, all the possible pair sums and the indexes I have stored inside the map. So what I've done is, in the map, with respect to the pair sum, guys, what I've done is I've stored the indexes here. Correct. Now, if you will see here, what will happen is, now whenever I come across any element, I'll check whether negative of that element exists in the map or not. So when I come across this particular element, that is 0, I'll check whether minus 0 exists or not. Minus 0 is 0 only, so it does exist. Now currently the index was 0 that I was at, and I can see that I have got 1 comma 4 here. Correct. So you can see that with respect to this zero sum, I've got 1 comma 4 as the indexes. So there are two indexes, 1 and 4, which are making the sum as 0 as well. Okay, so this means that my triplet does exist. So store this in the result. So in the result, what you will do is you will store the triplet in the sorted format. So you'll store 0 comma 1 comma 2, because if you were at the index 0, the element was 0 as well. So you checked for minus of ARR 5, you checked for minus of 0. Minus of 0 is 0 only. It existed inside the map. This meant that there were two elements whose sum was equal to 0. You can see minus 1 and 1, their sum was 0. So 1 comma 4 is the pair that you have got in the right side of the value here, this part. Correct. Now if you see, index was 0, ith index was 0, and the other indexes stored in the map are 1 and 4. So these three indexes are different. So in that case, you will store the pair as 0 comma 1 comma 4. Sorry, I had stored 2 earlier, but you have to store 0 comma 1 comma 4 here. And remember that you will take a set, because you do not want to store duplicate triplets, and you will always store the triplets in the sorted format. So another time, if you insert 0 comma 1 comma 4, so you will skip this particular pair here. You'll skip this triplet, because duplicates will not be stored inside the set. Now after that, if you will see here, next time what will happen? Next time I'll come across this particular element, that is minus 1. Now when I come across this element minus 1, so I'll look for 1. Does 1 exist in the map? Yes, 1 exists in the map. So if 1 is existing in the map, it is having two pairs, 0 comma 4 and 1 comma 2. Now if you see here, 1 exists in the map with these two. Now if you see, so as of now this index is 1, and the very first pair that is stored is 0 comma 4. So index 1 is there and 0 comma 4. All these three elements are different, but if you will make the pair, it will be 0 comma 1 comma 4, which is already stored inside the set, so it will not get stored here. Okay, then after this, what will happen? Next up, you'll go to the next up, you will check this particular pair. So as of now, you are at the index 1, and you can see that in this pair, 1 comma 2 is stored. So since the ith index was 1, and one of the indexes here is also 1, so we cannot include same elements here. Correct. We cannot include the same indexes here. So we have to skip this. Okay. And after this, what will happen here? Next, my index will move forward. So my I will be where? Now my I will be at 2 here. Now when I'm at 2, what will I check? I'll check whether when I'm at the index 2, the element is also 2. So I'll check whether minus 2 exists or not. Okay, does minus 2 exist in the map? If you will see here, so it does exist. It exists at the indexes, and it is having the indexes 3 and 4. So this means that currently I wanted minus 2, and there are two elements whose sum is minus 2. These are the two elements here. So the indexes stored are 3 and 4. So as of now, my index was 2, and in the map I can find index 3 and 4. Since all these three indexes are different, so I can store this. So store 3 comma 4 here. Sorry, store 2 comma 3 comma 4 in sorted format. Correct. Next up, what will happen is, if you'll proceed further, then when you'll go to this particular element here, so you'll check whether inside the map 3 exists or not. So if you see, inside the map 3 does exist, and you are having 2 comma 4. So as of now, you are at the index 3, and you're having 2 comma 4. So the triplet made will be 2, 3 and 4. Now this will not get inserted again, because you're using a set. Okay. And after this, if you see again, the next index will be index 4. Now after this, the element that you'll be looking for is minus 1, because you're looking for minus of ARR 5. So you can find it here. You can find it here. But if you see here, you have got 0 comma 1 and you have got 2 comma 3 here. Correct. So since you have got 0 comma 1, so this is different, but when you will make the triplet, it will be already there. So this will not get stored. Okay. And then after that, if you see this index is 4, and another pair is stored as 2 comma 3. So 1 comma, like if you see here, so 2 comma 3 comma 4, again this triplet is already there, so I'll not store it. Correct. So only unique triplets will be stored inside the result here. So the main thing is that you already have stored the pair sum inside the map. With respect to the pair sum, you have stored the indexes here, pair of index. Okay. And then after that, you will check if minus of AR of I exists in the map. Then you will check if all the three indexes are different. Then you will store the triplet. If you are storing duplicate triplets, so that will not get stored inside the result here. Now, if you see here, what will be the time complexity for this code? One of the cases can be, so yeah, with respect to the pair sum, you can understand that I'm storing the indexes here. Correct. I'm storing the indexes here. So the thing here is, guys, if with respect to the pair sum, I'm showing the indexes here. So the thing that might happen is that with respect to one sum, in the worst case, I might store n square pairs. Okay, because suppose that if array is given in such a way that this particular sum is repeating the most number of times, a particular sum is there. Let's say that sum is equal to, let's say 4. It is repeating most number of times, and it is storing again and again. It is storing indexes here. So in the worst case, how many indexes can be stored? N square indexes can have the sum as 4. Okay, because if you see, let's say this index has the sum as 4 also. This particular, these two indexes have the sum as 4. These two indexes have the sum as 4. These two indexes have the sum as 4. So in the worst case, how many elements can get stored in this map of 4? In this map of 4, n square elements can get stored. So you can understand one thing, that with respect to one particular index, I might have to iterate order of n square times. Correct. So with respect to n indexes, in the worst case, I have to iterate how much? I have to iterate order of n cube times. In average cases, the time complexity will obviously be n square, but in the worst cases, the time complexity is going to be n cube, because with, like, if a particular sum repeats again and again and it stores the indexes here. For example, the first pair, second pair, third pair, all are having sum as 4, then they will get stored in the map of 4, and the map of 4 will be having a lot of index pairs. So yeah, with respect to map of 4, what will happen is I might have to store n square pairs. So with respect to with respect to the sum as 4, suppose if I'm storing n square pairs, then with respect to one element of the array, I have to iterate n square times. So with respect to n indexes, I have to iterate n cube times. So this will be the time complexity in the worst case. Let's see the code here. If you will see, initially we'll declare a resultant set, then we'll take the n value, then we'll declare the map, and now we'll iterate. Like my I loop will run, my j will run, and the sum of the ith and the jth element will be taken. Okay, if this particular uh, sum is not there inside the map, then you will declare empty list for the map with respect to this sum. And if it is already, after that, with respect to this sum, you will store the indexes I and j here. Okay, so basically what we are going to do is, with respect to the pair sum, we are going to store the indexes I comma j here. Okay, then after this, what is going to happen? After this, we are going to iterate I in range n. Then after that, the other element that we are looking for is minus of AR of I. We'll check if it exists in the map or not. If it does exist and all the three pairs are different, because already in this pair, P0 and P1 indicates the indexes that are stored in the map. Okay, and I is my current index. So if all these three indexes are different, then we'll store them in the sorted format, and then we'll add them inside the tuple here. Okay, inside the result here in form of tuple. Then after this, we'll return the list of the triplets here in the end, after taking the resultant set here. I hope you have understood this clearly. Now let's try to submit this code as well. So you can see here that my code got accepted. Thank you for watching this video, and keep coding.